Now we're going to look at solving systems by using an algebraic method, specifically substitution. So our key terms, non-graphical methods for solving systems of equations are called algebraic because we use algebra to solve instead of graphing. One way to solve a system of two equations is to substitute an equivalent expression for a variable into an equation. When we use a substitution method, if neither equation of a pair has a variable alone on one side, we solve one equation for one of the variables, and sometimes it is easier to translate a problem into two equations into variables. So here we have a system. We're going to use substitution method. I'm literally going to substitute one equation into the other. Since my top equation is y equals, that means wherever I see a y, I can substitute 3x minus 2. What this does is it gives me a brand new equation with only one variable in it. And if there's only one variable, I can solve for that variable. So now I distribute combine my like terms, and now I can solve. So it looks like x equals 1. Now recall, the solution is an intersection point. In other words, it's a coordinate. So my answer, I only have half of it. I have the x coordinate. So how do I get the y coordinate? Well, if I think the answer is x equals 1, then I'm going to take one of my equations, and it doesn't matter which one, and I'm going to substitute my 1 in that I got in the previous work and find my y. So it looks like when I plug in 1, I also get 1. So my final answer is 1, 1. If I were to graph these two equations, they would intersect at 1, 1. So substitution works really well if one of your variables is isolated. If it's not isolated, then you're going to have to manipulate one of the equations, which is what we're going to have to do in this system. 7x plus 2y equals negative 4, and 8x minus y equals 2. I don't have a variable that is isolated, so we need to pick one of our variables to isolate. I think the easiest one to isolate is going to be the y in the second equation. So I'm going to manipulate this equation real quick. Get y by itself. And then I will be able to substitute into the other equation. So now that I have y equals 8x minus 2, I can take that 8x minus 2 and I can substitute it in for my y in my top equation. So that's going to give me 7x plus 2, and instead of y, I'm going to put 8x minus 2 equals negative 4. Distribute. Combine like terms. And solve. So I'm going to add 4 to both sides. Looks like I get 0. Divide both sides by 23. And I'm going to get x equals 0. Recall that that is only half of our answer. So how do we get the other half? I use substitution. And I can use one of my originals, or I can use the one that I created right here. That's going to be the easiest one to plug into, because I'm going to get 8 times 0 is 0 minus 2, so I'm going to get negative 2. So my final answer is 0, negative 2. So again, if I were to graph this system, my lines would cross at 0, negative 2.